Hello students, today we will discuss the properties of whole number, right? That is closure property, commutative property, associative property, property of zero for only for addition and subtraction. Next are the what? Multiplication and division we will solve in our next class. So before starting, let us recall what we have discussed in our previous class. In the previous class we have discussed what is a whole number, a representation of whole number in the number line, then successor, predecessor, like this, right? Then we have. So let's start with the first one, that is closure property. Here first will be what? Properties of addition and subtraction. So the closure property of addition says that the sum of two whole number is always a whole number, right? Suppose consider a whole number 3 and another whole number 4. Now sum means what? Plus. So add. So if we add 3 and 4, the result will be what? The result will be 7, and 7 is also a whole number. So closure property of addition says us that. Now here because there are numerous numbers of whole numbers, so we have considered the whole numbers with a and b. Suppose let a and b be two whole numbers, then the result will be what? The result we considered as c. Then c equals a plus b is also a whole number, right? This property is known as closure property. So let us see, the sum of a two whole number is always a whole number. Up to this clear? Now let a and b be two whole numbers, then c equals a plus b is also a whole number. This property is known as what? Closure property. Look here, we have taken example. Suppose in this case consider 4 as a and 6 as b, right? And 10 as what? C. So 4 plus 6 is how much? 4 plus 6 is 10, right? So is 10 a whole number? Yes, 10 is a whole number. Because we know what is a whole number? The numbers which start from 0 and moves towards right and goes to infinite are known as what? Whole numbers. Another one, 2 plus 3 equals 5. Is 5 a whole number? Yes, 5 is also a whole number. So this is what? This is closure property of addition, right? Now what? Closure property of subtraction. Look here. This is a bit different one from the addition. Here the difference of two whole number is not always a whole number. Means what? When we difference means what? Subtract. When we subtract a whole number from another whole number, the result is not always a whole number. Always means it will be not always a whole number. It may be another type of numbers also. That is, it may be negative numbers, or it may be a whole number. But to parallel, it may also be a negative numbers also. So look how. Let a and b be two whole numbers. So like this, let a and b be two whole numbers. Then a minus b will be a whole number. When? A minus b will be a whole number if a greater than b. Suppose consider a number 7, a whole number 7 a, and another number that is b. Okay, consider as 4. Now 7 minus 4 is how much? 7 minus 4, the result is 3, right? Here a is greater than b, that's why we got the result as a whole number, right? That is a greater than b, or a equals b. That is 7, a is also 7, b is also 7. So if we subtract 7 from 7, that is 7 minus 7, the result will be what? 0, and we know 0 is the smallest and the first whole number, right? Another case, what? If a less than b, that means here a is what? A is suppose consider 4 and b is 7. So 7 is greater than 4, right? That means 4 is less than 7. The result will not be a whole number. That means what? If we subtract 7 from 4, that means 4 minus 7, the result will be what? the result will be minus 3, right? The minus 3 is what? Minus 3 is a negative number. Hence, closure property. So, is the properties of all is subtraction is always a whole number? That means I want to say that when we subtract any whole number from another whole number, is this always a whole number? No. That's why closure property does not hold good for subtraction of all whole numbers, right? For example, let us look 19. So here 19a and 12 is what? B. So here a is greater than b, right? So 19 minus 12 is what? 7 is a whole number, right? Now second case, a equals b, that is a will be also 19 and b will also be 19. So 19 minus 19 equals what? 0. 0 is also a whole number. The third case, a less than b. So a is what? 12 and b is 19. 12 minus 19 equals how much? Minus 7 is not a whole number, right? Because we know whole numbers start from 0, then moves towards 1, 2, 3, 4, like this it goes to the infinite. So minus 7 is not a whole number. So let us recall again the closure properties of both addition and subtraction. In addition, what happens? When we add two whole numbers, the result is also a whole number. For example, here we have taken what? 4 plus 6. 4 is a whole number, 6 is also a whole number. The result is what? 10. 10 is also a whole number, right? You cannot find any whole number. Suppose when you add two whole numbers, the result will be negative. It is impossible, right? In subtraction, there are three cases, right? When we subtract a smaller whole number from a larger whole number, that is when suppose here like this, when a is greater than b, we find the result will be what? The result will be a whole number. When a equals b, in this case also the result will be a whole number, right? But the main thing is what? When a is less than b, the result will not be a whole number. For example, I have shown you there three examples of each, right? Here 19 minus 12, that is a greater than b, equals 7 is a whole number. 19 minus 19, that is a equals b, a is equals 0 is a whole number. Then 12 minus 19, that is a less than b, equals minus 7 is not a whole number, right? Okay, now let's move to our second property, that is commutative property. This property tells us that what? When we add two whole numbers and then rearrange their places. Suppose first case, let the two whole numbers be a and b. For first case, what? A is in right side, right? Right side, and b is in what? Sorry, a is in left side and b is in right side. The result will be same when we change their positions also. When we take a to the right side and b to the left side. For example, like this, a plus b equals b plus a. To understand this, let us take one example. Let us consider two whole numbers that are, suppose 5. Suppose consider a as 5, right, and b as suppose 4. The result will be what? The result will be 9, right? Now when we rearrange their places, that is, we have taken 4 to this side and 5 to that side, right? So 4 plus 5, 4 plus 5, the result will be what? The result will also be 9, right? So can we write this as 5 plus 4 equals 4 plus 5? Can we write this? Yes, we can write, because 5 plus 4 is 9, 4 plus 5 is also 9. That means 9 equals 9, right? So this is what? This is commutative property of addition, right? So now for subtraction, here what? If a and b are two whole numbers, then commutative property of subtraction tells us that a minus b not equals b minus a. Means what? when for example, let us take these same two whole numbers, right? It will be what? It will be better for you to relate what is for addition and what is for subtraction. So let the first number was what? 5, second number 4. 5 minus 4, the result is what? 1, right? Then 4 minus 5. 4 minus 5, what? The result is 4 minus 5. The result is minus 1, right? So now 1 is a whole number. Is 1 a whole number? Yes, 1 is a whole number, right? Now is minus 1 a whole number? No, minus 1 is not a whole number, it is a negative number, right? So 1 not equals minus 1, right? क्या 1 और माइनस 1 सेम है क्या? नहीं, ये दोनों नंबर सेम नहीं है, क्योंकि ये दोनों नंबर क्या वैल्यू डिफरेंट है. 1 is one thing and minus 1 is what? Another thing, right? So can we write this minus 5 minus 4 not equals? When we write equals and when we cut this equal sign, this represent what? Not equal. Minus 5 minus 4 not equals 4 minus 5, right? We consider what? 5 as A and 4 as B, not equals B minus A, this line, right? A minus B not equals B minus A. Hence, can we say that subtraction of whole number is not commutative? Yes. So you can write here subtraction of, hence and subtraction of whole numbers is not commutative, right? So here what can we write? Hence addition of whole number is commutative. Write this. Hence addition of two whole numbers is commutative. Clear? Okay, now let us move to our third property, that is associative property, right? Till now we have considered only two whole numbers, but in this case we have considered three whole numbers. So let us look what the associative property of addition tells us. Here, if A, B and C are any three whole numbers, suppose A, B, C are three any whole numbers, then A plus B first bracket plus C equals A plus first bracket B plus C. That means what? Suppose A plus B plus C equals A plus B plus C, we can write. Now it is not necessary to add all the whole numbers as given in the order, right? We can add this in our easiest way. So for making the addition easy, we make some group. We make groups, right? For like this, we make one group A plus B. We have separated A C from this, but here we have make another group B plus C, and then separated what? A. So let us see an example. Suppose let us take any three whole numbers. For example, 5 plus 6 plus 9. Okay, that is A is 5, B is 6, C is 9. Then equal sign. Then here also 5 plus 6 plus 9. like this, right? Now here, look here, we have given what? First bracket. Now look, 5 plus 6 plus 9, if we add 5, then with 5, then if we add 6, then the result will be what? 11. Then if we add what? 9. It is a long process, right? We have to add 3 times. Now if we look, if we just by seeing, can we say 5 plus 6 is how much? 5 plus 6 is 11. 11 plus 9 is how much? 20. 20, right? Then here 6 plus 9, 6 plus 9 is how much? 6 plus 9, 15. 15 plus 5, 20. This process what? This process helps us to add. This process helps us to add faster or in easy way. So this is equal sign, right? So associative property holds good for addition, right? That means what we can, when we rearrange whole numbers and add them, the result will be what? Same. For example, if we take any 3 whole numbers, a plus b plus c here, and if we give bracket a plus b in, if we took a plus b in bracket and b plus c in this case b plus c in bracket, the result will be what? Same. For this I have shown you an example, right? Now for subtraction, is it same or different? Let us have a look. Here a, b, c are whole numbers. Then look, for we will take same whole numbers. Suppose 5 minus 6 minus 9, then bracket, the result is what? The result is 6 minus 9 is how much? 6 minus 9 is minus 3, right? So 5 minus minus 3, right? So can we say this 5 minus minus will be what? Minus minus will be what? Plus. So the result will be what? 5 plus 3, that is 8. Now for this case, this is for this case, right? Now we will consider this case. 5 minus 6 minus 9. Okay, what? Bracket. Then 5 minus 6 is how much? 5 minus 6. 5 minus 6 is what? Minus 1. Then minus 1 minus 9. Minus 1 minus 9. The result will be what? Minus 1 minus 9. The result is minus 10. Right, now look, this is what? This is 8, and this is what? This is minus 10. Are they both same? No, they are not same. That's why associative property for subtraction is also not possible. In this case, it is possible, right? So now let us move to our last properties, that is it is different for each. For addition it is known as what? Identity element, and for subtraction this is property of 0. The main basic thing is what? Same. When we add 0 with a whole number, right? So can we write their name? Property with 0. Okay, when it is property with 0, it is known as what? Identity element, and for subtraction it is known as what? Property of 0. So let us have a look here. If 0 is added to a whole number, the sum is the number itself. Means what? When we add 0 to a whole number, for example, let us take any whole number 9. So when we add 9 with 0, the result is what? The result is the same whole number, that is 9, right? whether we add 0 with 9 or 9 with 0. 0 with 9 means what? 0 plus 9. The result will be what? 9, like this. 0 for here, the 0 plus a is what? A, and 9 with 0 means what? That is a plus 0. The result will also be what? 9, right? So can we write a plus 0 equals 0 plus a equals what? A. So for this case, this 0 is known as what? This is known as what? Additive identity. Okay. Now for subtraction, if a is a whole number, then a minus 0 is what? When 0 is subtracted from a, the result will be what? The result will be the whole number itself, that is a minus 0 equals what? A. But when a is subtracted from 0, that will the result be same? It will not be same, right? 0 minus a will be what? It will not equals be what? A, because it will be what? A negative number, right? So these are the 4 properties of the whole number for addition and subtraction. First one is what? First one was closure property. Second one was commutative property. Third one was associative property. Fourth one is what? With property with of 0. Okay. So in closure property, what we have discussed? When we add two whole numbers, the result is the what? The result is the number. The result is also a whole number. In addition, when in subtraction, when we subtract a whole number from another whole number, the result may or may not be a whole number. It depends on cases. 3 different situations. If the first number is what? If the first number was greater, then the result will be what? A whole number. But if the both numbers are same, the result will also be a whole number. But if the first number is what? Smaller, then the result will be what? Will not be a whole number. Second was what? Commutative property, right? Here in commutative property, when we add two whole numbers, that is a plus b, the result is what? Same as b plus a also. But in for addition, but for in subtraction, the results are not same. Same for associative property what tells us that we regroup the numbers for our better addition and subtraction. Okay. For this is also same. For addition, when a, b, c are regrouped as a plus b with first bracket, then c equals a plus b plus c. When they are in the bracket, the result is same. But this is not same for subtraction. Then last one is what? Property of with 0 or property of 0. In this case, when we add 0 with a whole number or a whole number with 0, the result is the same, that is the same whole number, and this 0 is known as what? Additive identity. But for subtraction, when we subtract 0 from a whole number, the result is the same whole number, right? For example, a minus 0, the result is what? A. But when we subtract a whole number from 0, the result is not same, because it will be what? It will be a negative number. For this, up to today, we will solve both exercise, that is for exercise for addition and for subtraction, in our next class.